good thing. Right now, what we're looking at doing is trying to pick up the spring semester and lay the groundwork for everything that we'll accomplish up until the end of the semester where we go to our competitions. So if you're coming in now, it's a great place to jump in. We've got a lot of work to do, and if you've been here before, I'm glad you're back. So today, some of the things I want to go over that I talked about briefly in an email is that there's a new competition on our horizon in addition to the one I spoke of that we've been working on all last semester. And that brings with it new payloads and the design that we've all been working on. Luckily, with this new competition, we don't have to change a whole lot from our design, and everything we've all been working on is still intact. We're looking at manufacturing coming up soon, testing, our preliminary design review presentation, and then at the end we'll do polos if you already ordered one. So to start off, the new competition is sponsored by NASA. It's called NASA Student Launch. Historically, this has been the competition that the rocket team has tried to pursue and compete in, and in the past it was the University Student Launch Initiative. They didn't announce that they were actually doing this competition until very late November after our last meeting last semester. So that's why since then we decided to do this. The good news is that a lot of their requirements line straight up with that intercollegiate rocketry engineering competition. So we can go ahead and use the same vehicle for both competitions, which is really awesome. Just to summarize what this competition is all about, we're designing, building, testing, and launching a rocket with 3 payloads up to any height that we determined. So, in the to go along with the other competition, we set that at 10,000 feet, so we're agreeing there. And we will be doing 3 payloads, which they have actually required us to do, and I'll get into that a little bit later. We'll be giving a whole bunch of reports throughout the semester, which actually I know some of you even started working on for the preliminary design report, which was due last Friday, so for everybody who worked on that, thank you. And we'll be doing a lot of engineering emphasis, like going through the whole process, as opposed to the last competition, which was just a lot more hobby rocketry and emphasizing student-built products, but this is going through the entire process, so all the design, the testing, and the analysis, which they want to see a whole lot more here. Which is good for us, which means we get to experience everything in the real world. And one really cool thing about this project, in the way that NASA was able to fund it for us this year, is that they're intending it internally to be a research project for Space Launch System. So we're doing, some of the payloads we're doing is actually, if we do well enough, it can have a direct impact on what they're trying to accomplish in their newest vehicle. And that's pretty cool. And then when I send this email out later, or send this out in an email, you can follow that link on the bottom, and it has a whole handbook for all the rules and regulations and details about this competition, so you can look at that in depth. Now, one of the biggest things is that the payloads they're requiring are very specific. So the first one is a ground scanning system. And the idea behind this is that we have a camera on board that's supposed to take pictures, scan the ground, and have software that determines if there's going to be a hazard on the ground when we land there. We don't have to mitigate that hazard or move anywhere else. We just have to recognize it and then send that information back to the ground. So that's our first payload. And this one, unlike most payloads, is very engineering in nature. There's a goal, and we have to design some sort of system to accomplish that goal. Whereas the other 2 payloads are scientific. We have an experiment on board, and we're trying to gather data and verify some certain hypothesis. So the first of those is a boost systems analysis. And the idea behind this is that if we put some strain gauges, which are basically some instrumentation that you can measure the response in a material, if we put those on the lower section of our vehicle, we can characterize all the forces that are present as we thrust up. And from that, we can see how well our particular design distributes that force throughout the rocket instead of localizing it in one specific location. So that's the goal with this payload. And the last payload is the trickiest payload. It's an analysis of the triboelectric effect. And that effect is, it's basically a charge buildup when you rub two things together. So when you rub your socks on the ground and you have that static electricity, that's the exact same effect we're experiencing here. But in aerospace applications, that happens as the air rushes over in the airframe of the vehicle. So any particulates that crash into the vehicle can actually strip off the electrons and build up a charge on the outside, which is really bad if you're trying to communicate to the ground or do anything like that. So on aircraft, you see a lot of those like static wicks at the back, so those metal probes sticking out the back of the swing. Those are ways that like aircraft will typically discharge that static. And that's one thing that's commonly known as how to deal with this whole phenomenon. However, what's not commonly known are a lot of the characteristics of it. So that's what we're going to be trying to do, is characterize the impact of this phenomenon rather than just trying to mitigate. So what we're going to try and do, and excuse this poorly made paint graph, but what we're going to do is we're going to launch our vehicle and have that charge build up throughout the flight, and at some predetermined point in the flight, we're going to go ahead and discharge that static. And when we do that, we should see a huge jump in signal strength. So we can actually characterize how important that effect is on all of our systems. It probably won't be that drastic of a jump, but I just exaggerated it there. So that's what these three payloads are, and those three payloads have influenced the design quite a bit. So right now I'm going to go over the overall design, just tip to tail. And this is everything you guys have basically been working on. So at the front, we've just got our nose cone, which we're going to actually end up manufacturing and fiberglassing ourselves, which is something we've never done before. So that's going to be really cool. In the upper airframe here, we're going to have our main parachute, which is attached to a piston, and on top of this electronics bag is our explosive charge that's going to separate at like 700 feet when we're coming down, so that way we don't impact really hard. And this here is our upper electronics bag, just the next section. And what's really cool about this design that we have there is that we've actually got a door on the front that we can take on and take off so that we can access all the electronics inside after we put the vehicle together. So, which is a problem we've had in the past. So that should be pretty interesting. And in the back, underneath this upper electronics bag, we have some baffles, which is another way to deal with these explosive charges and protect the parachutes. So I know Recovery's come up with a lot of that. Behind the baffles, we'll have our drogue parachute, which comes out at Apogee. Both of these parachutes we're manufacturing and building all ourselves in-house, which is, again, a totally new project that we're taking on for the first time. And then beneath that, we've actually got a lower electronics bay, and we needed to separate them out because a lot of our payload systems, so we've got a camera down here at the bottom and all the strain gauges back here, and all those systems are tucked away in the back. And when we separate, we can't really have a reliable connection up to the upper electronics bay. So we needed to have something permanently in the bottom. So we've got two electronics bays. And beneath that, we have our motor, and at the back, boat tail, which is just a conical section that should help with our airflow and reduce base drag. Again, we'll be manufacturing our entire airframe of the vehicle out of fiberglass, which is pretty cool. And actually, that's a pretty good place to jump into manufacturing. John, you want to talk about manufacturing in the shop really quick?
So, I'm John, I'm a propulsion flight dynamics lead. We are going to have quite a few parts to manufacture. Our subscale is coming up first. Our launch is on February 8th, which is going to be pretty soon. So a lot of manufacturing is going to have to be done quickly. That being said, we're going to have we're going to have a few centering rings and bulkheads to be done out of aluminum for the subscale rocket. If anybody's interested in manufacturing, I know some of you have already expressed interest. People that have already taken design and manufacturing lab or have experience on mills and lathes, definitely come talk to me if you're interested in helping out with the centering rings and the bulkheads. We're going to stick to people that have the experience already for the subscale because it has to be manufactured so quickly. As for the other things, such as cutting to the fins, putting everything together, go ahead and sanding the fins, we're going to need help rolling fiberglass, making the nose cone. All of those things are going to be done at the solar park. So for anybody else that wants to get involved with manufacturing, get your hands on material and actually start learning, you should definitely come out to the solar park, help us out. It's not like it's just going to be a lecture environment. You're definitely going to get your hands on some material and learn a lot in the process. We are planning I guess kind of a machine training session for mills and lathes and machine tools that you find in the student shop. That has not been scheduled yet, and that will be done definitely before the full-scale manufacturing begins. And so anybody else that is interested in manufacturing but doesn't have that experience, you should definitely come out to that, and then you'll be able to help out with the full-scale rocket. So as Jacob said, there's going to be a lot of manufacturing that's going to be done on this rocket, so there's a lot of learning to be done. Companies love that if you can get composite material or composite experience, so definitely come out and help us out. So you can talk to me after the meeting from here, or you can, Jacob has my contact info, and you can shoot me a text, shoot me an email, and I'll put you on the list and start moving some stuff around to get your hands on some stuff, all right? So just talk to me if you have any questions.
Okay, so that's pretty good for all the manufacturing. He gave a pretty good overview, but just to break it down into a lot of the specifics we're going to try and accomplish over the next week or so, not next week, next couple of weeks or so, sorry. As he said, the launch is February 8th, which is 23 days away, so we have to build an entire rocket from scratch by then, which is no small feat. So we're going to have a lot of different tasks occurring concurrently. So if any of these interest you, go ahead and talk to these people. So if you're doing a recovery and you want to manufacture the parachutes or work on the blast caps and baffles and the pistons, talk to Colin, and we'll get that scheduled in. Colin, you want to raise your hand? Yeah, that's Colin. If you want to help fiberglassing the body tube, talk to Brittany. I know she sent out an email, but everything's still open. And then talk to John if you want to get into the shop. We've got the fins and motor mount coming up later. And this weekend, up at the top, we're going to be in the energy park actually building the avionics bay. So that's where we put our altimeters, our charges, our bulkheads. It's basically the equivalent of our upper electronics bay, but just for our subscale. So if you want to do that, go ahead and get out there. And Arun is going to be the one leading that build over there. So what time? 10 a.m. 10 a.m. So 10 a.m. over there. If you need help getting out there and you're interested, you can email me and I can set up some way for you to get a ride out there, and just to make sure that everybody can be involved in everything they want. There's also, okay, so this is the subscale. I'm just going to switch gears. I don't have a slide for this, but it just popped in my mind. The full scale basically our design needs to be done in the next 2 weeks so that we can go ahead and order materials to start manufacturing that. So there's a little bit of design work that still needs to be done there. So after the meeting, if you want to help out with the actual design there, talk to your subsystem lead. So that's going to be Colin, Brittany, John, me. Talk to us about helping with the finalized design for that. And that's pretty important too. Okay, so moving on. Yeah, moving on. We've got some testing coming up. We actually already accomplished some in terms of fiberglassing. We built this, sorry, I'm jumping back. This stand, we manufactured it so that we can go ahead and roll our own tubes. So that's already done, and with that we've done a little bit of in-school testing with fiberglass. So we figured out a pretty decent methodology to get that accomplished. So actually here's the test, like a test tube that we made, and it's really strong. If you hold it in your hand, it's great to squeeze because it doesn't do anything, which is our goal. And it's a pretty good process, so we're happy with it. And pretty soon we're going to do some compression testing up on the Instron machine, which is up there. We've got to do some two-way communication tests coming up. We have to figure out some way how to discharge that static for that payload. We have a few ideas, but we need to actually test them out. Those are probably going to be happening over this weekend too, whenever we're doing the manufacturing with Arun. We've got some charge testing, so that's making sure that the charges we put into our rocket are actually going to separate and eject the parachutes. And then we have to calibrate our trim gauges. And all of this testing is coming up, and if any of this excites you, let me know and I can make sure you're involved in all that. And I mentioned earlier the preliminary design review, which was the big report that we had to do for this NASA competition. It was due last Friday. For everybody who wrote a section, helped with the design work on there, thanks so much. We couldn't have done it without you. It's up there. We don't have any feedback yet. That should be another couple of weeks. You can look at the finalized document on our website. We will be doing a presentation to NASA tomorrow from 2 o'clock to 3:30, and anybody's welcome to stop by and listen in. That'll be all the major details of the design we've come up with so far. If you do stop by, try and be there before 1:45. I don't have the location up there, but it's MAE 211. Let me write that down, just for anybody who's interested. So you can stop by then, and that's what's going on there. We're going to have another one of these major reports due February 28th, which is our critical design. So that's coming up. If you like detailed technical writing, this is your stuff. And just moving on to some other updates from around the team. I know there was a static motor test stand meeting. Was anybody here, like earlier today? How are you guys doing with that?
That's not really, the design's pretty much finalized. We have to work out the last little bit of kinks and analysis, and materials will be ordered soon, so.
Okay, cool. I know our hybrids teams have been working great. Kyle is on top of all that. Does somebody who's on one of the hybrids team want to tell us where you guys are in the process?
Sure. So we've got materials. We're still working on our bi-weekly reports that are due to the NASA competition, but we're going to start manufacturing really soon. All the teams out there have gotten the majority of the materials to go ahead and start. So.
Okay, that sounds like you guys are in a really good place. That's awesome. And then for our propulsion research side, does somebody from each of these teams want to just say where you guys are at in the process, where you're headed? Solids? Go for it.
For solids, we narrowed down to 2 different types of fuels, and we're doing the design making for that now.
Mm-hmm.
And we have some pretty good recipes we're looking at, and after we do that, we'll order the material again and get some custom reactions.
Okay, awesome. Liquids? Nobody from Liquids wants to speak up?
Sure. So right now what we're looking for is we're basically looking for where can we get the rocket fuel that we need to make our motors. That's the main kind of thing we're trying to work on right now. It's pretty hard to order rocket fuel when you're like, that's $22. So that's what we're trying to figure out right now. That's great to figure out.
Okay. And hybrid? Okay. Yeah.
We need to do like some design matrices and really narrow down what kind of fuel we want to use and how we're going to acquire that.
Okay. Great. I know I was talking to Crystal earlier, and her goal by the end of the semester was to have each of these groups go ahead and test something. So if we keep making progress on each of these fronts, we're definitely moving in that direction. So that's what I'm hoping for too. But I want to see each of these have a test by the end.
There's still a lot of work to be done, a lot of work that can be done, so the more people we get involved, and the faster that goes, the better job we do. That goes for propulsion research, all research, and static motor test stand. So if anybody feels like you are struggling to get involved or want something fun to do, the static motor test stand is a cool design project, and the propulsion research is a cool kind of R&D program, so definitely come talk to us after or do.
Yeah, and I will say for the other competition, not the NASA one, the one we've been looking at, it does allow homemade motors. So if we can get one of the design from any of these groups that's really solid, not necessarily solids, but a good design, we can go ahead and put it on our rocket. So that would be great. Just something to keep in mind. And I think that's all I really have. Does anybody have any questions about where we are, where we're going, about the design, anything? Okay, awesome. I've got some polos up here. If you order them, it's $27, and you can just get it right here. Thank you all for coming.